All right, so here we go. Talking about calculus definition of slope, a derivative. Using this is called the difference quotient. That's the name of this thing. We're not going to use it for very long because there's a whole ton of shortcuts we're going to use instead. But this is the basis of why all the shortcuts work. So instead of, algebra 1 y2 minus y1 over x2 minus x1, we're using this guy. Where f of x plus h right here, this is your y2 from algebra 1. Okay? This is your y1 from algebra 1. And the x plus h is your x2 from algebra 1. Okay? Minus the x, that's your x1 from algebra 1. What happens to those two x's? They cancel. And so I'm left with just the h, right? That's where the h came from. That's why it's on the bottom. So y2 over x2 minus y1 over x1. So you write your equation out. Leave a lot of room where the x goes. And you write your equation out again in parentheses with just your x in there. That's your steps. Write the equation out. A space in the parentheses for the x plus h. Then minus the original equation. Replace that space with x plus h right here. Distribute and combine like terms. So 2 times x is 2x. 2 times h is 2h. The 3 is here. Negative times 2 is negative 2x. Negative times 3 is negative 3. Now, who remembers at the end of this what has to happen? The h has to stick around. Everything that doesn't have an h in it has to cancel. Everything that does not have an x, an h has to cancel. So the 2x has to cancel the 2x. The 3 has to cancel the 3. If that didn't happen, you done goofed. Go do it again. Everything but the h's has to go away. You can mark the h's off, and there's your slope right there. Here's the same thing with a square root instead of a nice simple linear. Again, it's f of x plus h minus f of x. So there's a square root, leave yourself some room, minus the square root of x. So the square root of x plus h is what you got. There's a square root of x plus h right here, minus square root of x over h. Alright? To solve this, I can't plug a 0 in. To solve this, I have to conjugate. So I'm multiplying by this with a plus sign right here. That times that is
X plus h.
x plus h. This times that is negative x. Negative x, right? That's where those things came from. The bottom, you just leave it the way it is. What happened on top? Everything but the h is canceled out. So I'm with h on top. I'll put an h right there. I'm left with h on the bottom times that whole expression. Those h's are going to do what? They're going to cancel. And now plug 0 in to finish. I get 1 over 2 square roots of x. I plug a 0 in here to finish. A 0 there for that h. So square root of x plus square root of x is 2 square roots of x. All right, we good? Let's go try some. We're on.
So if one of the h's doesn't cancel, you plug in the limit?
Yes. Yes, yes. You plug the 0 in for any h's that's left. So we're out here on test day 2, right there. And we're doing 15 through 35 odd. I'm going to work 2 or 3 with you guys just to make sure we remember we're doing them right. There's Here's my equation, 15 plus 2/3 s. No, 3 plus 2/3 s, sorry. 3 plus 2/3 s. Alright, so f of x plus h minus f of x. Write your equation on the left with room wherever that variable's at. Minus the equation on the right, surrounded in parentheses, so you get the signs right. What goes where this s was?
X plus H.
X plus h. Distribute, combine like terms, and see what you get. Well, s is a placeholder. So I'm replacing s with x plus h. Okay? Over here I'm replacing s with, that should be an x, you're right, I'm sorry. I see what you're saying. That should be an x right there.
I'm leaving it at S's.
The variables are irrelevant, does not matter, okay? What cancels? Threes
2/3.
and the 2/3. Then the 2/3 h over,
H.
those cancel and my slope is 2/3, which you expected. It was a linear equation, right?
U.
That was a y intercept of 3, a slope of 2/3. We expected 2/3. Let's go do 17. That will at least be a little more fun. Two x squared plus x minus 1, 17. This will at least be a little interesting. So f of x plus h minus f of x. Replace all the x's with brackets. Leave yourself some room. Write the second equation out in parentheses so you get your signs correct. First off, what is x plus h squared?
X squared plus 2 plus h plus h squared.
Awesome. X squared plus 2xh plus h squared. It's not x squared plus h squared. Don't forget that middle term, okay? It is not that. Don't ever do that. That's bad. Gives you 2, and you have 2x squared plus 4xh plus 2h squared plus x plus h minus 1 minus 2x squared minus x plus 1. You do that. Alright. What cancels?
X's.
The x squares, the x's, and the 1s. Leaving me with 4xh plus 2h squared over h.
Plus h on the top, right?
Did I miss something?
Yeah, plus h.
Plus
on the top.
h. Thank you, sir. Right there. I missed that one. Thank you. Okay. Everybody got that? Alex, you got that? Okay. So at this point, you either need to undistribute an h on the top, or just start dividing an h out of every term. However you want to think about it, it's fine. It's safer to undistribute the h. Okay. If I take an h out of everything on top, I've got h times 4x plus 1. Don't forget about the 1. A lot of people do. Those cancel. That's my equation.
Plug a 0 in.
Plug a 0 in because don't forget, this is a limit as h approaches 0. So you plug a 0 in right there, and you get an equation of 4x plus 1. Who remembers what this means to me? It's not, it's just an equation. How is it useful? Remember, in calculus we're talking about the slope of a curve. The slope of a curve changes depending on where the curve you are. The slope here is very different than the slope there. This equation tells me the slope at any point on the curve. If I plug in a 0 here, okay, it's telling me when x is 0, the slope is 1. If I plug in a negative 2 here, so that was 0, there's negative 1, negative 2, something like that. If I plug a negative 2 in here, tell me the slope is a negative 8 plus 1 is negative 7. Very steep negative slope. It tells me the slope at any x coordinate along that curve. It tells me the velocity of a ball in motion at any point in time on its arc. Okay? That's what it's telling me. If I punt a football, it tells me the velocity when it leaves my foot. It tells me the velocity at the top of its arc. It tells me the velocity as it's coming to the ground. It tells me how fast it hits the ground. Does that make sense?
Mm-hmm.
Okay. All right. Y'all keep on trucking.